Hello and welcome back to my channel. Today we're going to be talking about geometric area. First thing we need to talk about is integrals. So integrals are the area under the curve. So when we talk about derivatives, we talk about slope. When we talk about integrals, we're talking about area of our function that we're looking at. The symbol for an integral is this right here. Some people call it a crowbar. The reason why a lot of times you see instruments like violins on covers of calculus textbooks is because that opening looks kind of like it looks like the integral symbol. We have two different types of integral. We have definite and indefinite. And you can tell really clearly and obviously when you look at the notation of which one's which. So when we're looking at a definite integral, you'll see that crowbar, the integral symbol, and then you'll see some sort of numbers or letters on that symbol. So you'll see an A and B. This is telling us the starting and the ending point. So A is our starting, B is our ending. And then generally some function that we're dealing with. Dx is our change in our x values. It's needed when we take these integrals. It's finding the width of our rectangle. Indefinite integrals, on the other hand, are talking about the function as a whole. So we just get this integral symbol and that's it. So there's no bounds. We're not looking at a specific portion of the function. We're looking at the function overall. Normally, when we would start looking at this integral symbol, we would be getting into indefinite integrals to kind of help us out here. But because we're going to be talking about geometric integrals, definite integral notation is something that shows up. So we're just talking about it now to kind of help us understand what these questions are asking. So when we're talking about geometric integrals, what we're really talking about, the area under the graph, specifically graphs that we can find the area using shapes. So let's talk about some area formulas. So we have the area of a triangle. The area of a triangle, we can think about it in two ways. Base times height divided by 2, or 1/2 base times height. Rectangles, we've been dealing with them, are base times height. Trapezoids, my all-time favorite shape, can be written as base 1 plus base 2. We're realistically finding the average of those bases times their height divided by 2, or 1/2 times all of that. So the last one that we're going to talk about here is the area of a circle. We have pi r squared. We need these different things to kind of help us decide what's going on with these different shapes, and we use these to kind of help us out. So use the following graph to find the area between x equals -1 and 6. So this graph is f of x. And if we were to ask this in a different way, it would be saying, what is the integral from -1 to 6 of our graph? In this case, it's f. So this is what we are asking for. This first graph is looking between -1 and 6. So we want this area right here. We want all of this area. So one thing that I notice here is that we are looking at a triangle. We could look at it as one non-right triangle, or we could split this up into two right triangles if we were to split it up here. It doesn't really matter. We just need to be thinking about the area of something. So I can make this one triangle, and we just need to find the base and the height. So this is going to be equal to, and this is exactly equal to because we can find the exact area. So we have 1/2 times our base. So our base is this entire distance. So we have our distance here is 6, but then we have one more over here. So 7 times our height. So if we go from the x-axis to the highest point here, it's this distance of 2. So we have 1/2 times 7 times 2. So 1/2 and 2 cancel each other out. They become 1. So we get 7. So our area would be 7 units squared. We don't know what the units are, so we're going to go ahead and just leave it for now. Okay. What is the value of the integral from -5 to 6? So now what we're doing is we're looking at this interval, -5 to 6. We just found all of this area here, which is 7. So we can kind of break up this problem into 2 pieces. So we're going to take this integral -5 to 6, and we're going to break it up into 2 different integrals. The integral from -5 to -1, so that starting point from our last one, plus the integral from -1 to 6. So we have already found that second integral, so I can already go ahead and say that we're going to add 7 to whatever we get. And then when I look here, we are looking at another triangle here. So this area right here that we're looking at is another triangle. But one of the things that you're going to notice is that it is in the negative region. So one of the things that we want to keep in mind is that if we are above the x-axis, our area is positive. If we are below the x-axis, even though we're finding the area, our area is going to be negative. So the amount of area that we're covering is going to be negative, just like the height would be. So we're going from -5 to -1, so we need 1/2 times. We're looking from -5 to -1, so if we look here, we have a distance of 4. So our base would be 4, and our height is 4, but we are going to make it negative because it is in that lower region. If we want to, we could find the area of that triangle and then make it negative, but because it's below, we need to make it negative in some way, shape, or form. So we have 1/2 times 4, which gives us 2, and 2 times -4 gives us -8. And we still have this plus 7, so our total area here is -1. So when we combine these 2 regions, our area between those two is -1. And then our last one here, we're going from -9 to +9. We've done some of it, but we haven't done a lot of this. So we have -9 to +9. So what we're going to do is we're going to break this up into different pieces. That way we can look at some of these a little bit easier. So we have done this section already. And we have done this section already. So we already know what these two are going to be together. So we know that they are -1 when we do -5 to 6. So we're going to do a couple different integrals here. I like to split up the stuff that is below with the stuff that is above. So I'm going to make 2 integrals for these lower pieces. And then I'll do one for this upper piece. We can make it 2 if we want to do right triangles, but it's a triangle altogether. And then we're going to go all the way over here, and we're going to do another one over here to do this piece. So we are going to break up this integral from -9 to -8, -8 to -6, -6 to -5. We'll keep -5 to 6 together, and then that's 6 to 9. So this integral negative 9 to 9 is going to be broken up into a bunch of little integrals. So negative 9 to negative 8. Plus the integral from negative 8 to negative 6. We have the integral from negative 6 to negative 5. We have the integral we've already solved for from negative 5 to 6. And then our last one from 6 to 9. The reason why we're going to be writing it out for right now is just so that way we get used to kind of chunking it out. Later on, we might be able to kind of put everything together and not have to write out each piece. Writing out each piece kind of just like grounds us into what we're doing. So let's start with negative 9 to negative 8. So negative 9 to negative 8 has a base of 1 and a height of negative 4. So we have 1/2 times negative 4 times 1 plus. We know we have another triangle, so I have 1/2. So our base is 2 and our height is 4. We have negative 6 to negative 5, which is going to once again be 1/2 times. Our base is 1. Our height is negative 4 again. We know the integral from negative 5 to negative 6 is negative 1. And then we have this last part from 6 to 9. So our base is going to be 3, and our height is going to be negative 3. So 1/2 times 3 and negative 3. So now what we're going to do is just simplify and then try to compact this down into one answer. So 1/2 times negative 4 times 1 is negative 2. We have 1/2 times 2 times 4. 1/2 times 1 times negative 4 we just found out was negative 2. We're adding negative 1 to it. And then we have 1/2 times 3 times negative 3, which is going to be a negative 9/2. So now we're going to simplify this the best that we can. Some things that I notice is that we have 4 and those negative 2's, they cancel each other out. They are the same area above and below, so we are going to make a 0 there. So what I'm really looking at here is negative 1 minus 9/2. Well, negative 1 is 2/2, so we have negative 11/2. We could change that into a decimal if we really wanted to. It would be negative 5.5, but I could also just leave it as negative 11/2.